So all that has been said here, adding to that, there's so much changing. In fact, the RAN is changing in many ways in terms of the architecture, the software. There's a lot of upheaval right now in this area. And who better to speak about all that than Rob Soni, my colleague, who's the VP of RAN technology at AT&T. And his team is, in fact, looking at some of these things and very strongly involved in many of the initiatives that are taking place. Open RAN a few years back and continuing. And also now a member of actually one of the founders of the Okudu Ecosystem Foundation. So, I was very fortunate to run into Rob back in Austin a few months back at one of the events over there, UT Austin. And, we go back a long way. I mean, as graduate students, we are reading each other's papers. Rob reminded me of that, and it was great to hit off again after all these years. So Rob kindly accepted to join us here. Rob, please, your title of your presentation is Evolution and Revolution, or Revolution. So I think, this is really appropriate. And yeah, let's welcome Rob.
That's forward?
Okay.
Good morning. No, good morning back. I'm trying to stretch out my old professor muscles to see if I actually have people paying attention or engaged. First of all, thank you, Irfan, for inviting me to come here. First trip to Portugal, first trip to Porto. Beautiful country, wonderful people. Really grateful to be here with my wife. She is here. We're looking forward to doing some touring after this. But thank you also to Raymond and to the FEUP faculty in particular for hosting us here. This is, I think, a good opportunity to engage what seems to be a very active developer, consumer community of the OAI group. So I'm going to give you some things. I hope you feel comfortable. If you want, you can interrupt me and ask a question. Don't feel that I'm just here to speak. Now, we do have a panel later, and there may be more opportunity to ask questions then. But less important is actually going through the slides and connecting with you and understanding actually why you want to do open source. Why do you think it ultimately is valuable to you? What does it actually mean? We're on the cusp of a new G. There's a lot of excitement. I was at Network X in Dallas a couple of weeks ago, and the most oversubscribed sessions, standing room only, were the 6G sessions. People were teasing me afterwards that it was really your sessions because the room would fill up when you were coming in and leave empty when you were leaving. I said, I don't think so. But reality is that people are very interested in where 6G is going. And I kind of resonate a little bit on where we were 3 years ago, especially for AT&T in particular. So AT&T is celebrating 150 years of innovation, 150 years since really the foundation of AT&T, and 150 years of that famous patent, which I guess if you are Italian, maybe you dispute whether it should have been given to AT&T or not. But if you are American, we all believe that, yes, it belonged with Mr. Bell, with Alexander Graham Bell. But appreciate, that it's a 150-year-old company that has gone through a lot. It was a million-man-person company, 1 million people in 1984 at the time of divestiture. It's hard to think about that it was a million-person company, largely serving the needs of the U.S. only for telecommunications. Today, we're roughly 100,000. Providing a lot more complex array of services than, frankly, we did then. In the meantime, in many cases, we still haven't unwrapped or unwired, as it's often called, a lot of services that are legacy. So for us as a company, we are going through significant transformations. We tend to think that we are now a 150-year-old startup as we focused 100% on connectivity, got out of the media business, got out of the cable business, got out of the local, and now trying to get out of the copper business. So trying to get out of the businesses which drag the bottom line and ultimately we only see deterioration finally in the top line. And we even changed our financial reporting. We're finally bold enough, brave enough to admit this last quarter that legacy is now full on in decline, and we want to actually let everyone be aware of how much legacy is declining, but also how much potentially 5G and fiber are growing. So this is a change. It was a change for me as an engineer. I spent most of my career on the vendor side. I started in Lucent, which was ironically a spin out of AT&T. Lucent got acquired by Alcatel, and I was in Alcatel-Lucent. And it's interesting that there is a connection between myself and Laurent, that ultimately when he retired from Bell Labs, I came into Bell Labs in the Nokia days, and I had his team for a little while. And that team was actually actively contributing to OAI. Many of those researchers are now retired. But that was the first time that I really got, I would say, deeply exposed the idea of using open source in particular for the support or for the benefit of research and innovation on the industrial side. I think a little bit about the conversations that Irfan and I had, and I still remember quite vividly when I was a grad student and trying to build libraries to do and code IS-95 for CDMA or UMTS Release 99, and some of the challenges of being able to write the code. There wasn't a huge code base available, and then we tried to do it in MATLAB of all things, and that was before the concept of compilers and speed up and acceleration was there. And we'd have this constant battle, and researchers would fight each other over who was getting done faster because they either rolled their own code in C or C++ versus if they wanted to do it with MATLAB. And it was interesting that as I transitioned and started working in the companies, it was actually the best skill that I learned was to be able to write code from scratch, to be able to do that. And then, of course, once those code bases became huge, they often became unwieldy. So they often became difficult for us to maintain. But I want to get into a little bit about really why are we here? Where did we come from? I mean, many of you know the journey. I started mine not in the 1G era. I'm not that old, unfortunately or fortunately. But I will tell you, I was graduating from grad school and working in the middle of the peak of the 3G era. Lots of debates about what was the right system for modulation between the 3G and 4G era. I still remember my boss coming and tapping on my shoulder every day and saying, "Why aren't you working on WiMAX?" And I said, "Because LT is going to win." And he said, "Okay, but do you want to have a job?" I said, "Okay, I'll go work on WiMAX for a while." So, but I think I won. Anyways, LTE era was important to us because it did a couple of things. It flattened the network. It gave the opportunity to bring true mobile broadband available. Even though I spent a lot of time working on HSDPA and HSUPA, or HSPA as it was called, we realized fundamentally the network was impeding as well as the air interface in terms of truly being able to provide the kind of broadband experience you wanted over a wireless interface. Of course, all we do when we get to 5G is we get more antennas, more bandwidth, higher data rates, lower latency. But finally, the challenge, we don't get money. Finally, the opposite direction happens. ARPUs deteriorate around the world, which causes a lack of investment, less jobs, less interest overall in our area, which is interesting because I think now we're into the 6G era. And so the CEO of our company, famously, he was at a town hall in Kista at Sweden, and this was in 24. He sat there, and I'm sitting there, and I'm already in 24 working on 6G, like many of you. And he says, "We don't want 6G. We don't want 6G. I said, "What am I working on this for? Why should I work on 6G if we don't want it?" So the whole flight home from Sweden, I kept thinking to myself, what does he really mean? What he really means, finally, is that he doesn't want the standard way of doing things, the way that we had progressed between the 4G, 5G era. We have to have and look at 6G from a different perspective. We need to re-engage, and we need to think about how do we move towards software-driven? How do we enable software-driven innovation? What are the key tools and key enablers? Now, we've seen NVIDIA emerge as one who's proposing and advocating a different form of software innovation, specifically for layer 1, but now expanding to layer 2 and thinking very carefully about what they do for network optimization. So they are providing very powerful tools for us, and we're looking at all of them today in the network, but really thinking about how do we move out of the space where we are so tightly coupled to hardware. The irony, of course, is that NVIDIA is pushing their hardware. But at the same time, we look at the opportunities now to be able to really aggressively move forward with the 6G era to offer new services, new capabilities. And this is really the testing point for 5G. Can we find a way to offer differentiated services? And the company is experimenting with this quite heavily right now. You guys, are there any World Cup fans here? Anybody watching the World Cup? Only one person? So today, when you go to a World Cup stadium in the US, as soon as you walk in, if you are an AT&T subscriber, you get a text message saying, we'll offer you a new service called Turbo Live. And that service, Turbo Live, which is just being tested right now, allows the user to get a significant boost in both uplink and downlink throughput. And this is enabled largely through software-based innovation. No changes to the physical layer, no changes to the scheduler behavior, but largely as a software-based innovation, as a push, as a network slice. Except we don't really call it that, because we offer it on NSA as well as we offer it on standalone. Everybody knows the difference between NSA and NSA? I think we're mostly in a RAN crowd here. Sometimes I give these talks and I will ask people, I said, do you know what RAN is? And they'll look at me funny and they say, what is RAN? So I have some slides, believe it or not, thankfully they're not in this deck, showing what does a cell site look like, what are antennas, what are base stations, but you all know what that is. Anyways, the simple thing is in a stadium venue, you can now get a significant boost up. You pay a fee for the duration of the event, and the service that we provide is, I will frankly say, is exceptional. It's a priority-based method. It gives higher priority to those who pay for it. And, well, frankly, people want to pay for it. Now, is it going to scale at the rate that we think that traditional subscribers will grow? We're still trying to find that out right now. But I think this is the first large-scale experiment. We started first with a subscription-based service available on a monthly basis called Turbo. Very exciting marketing people. We went from Turbo to Turbo Live. But Turbo was a subscription-based service on a monthly basis. So this service now gives us the opportunity to offer differentiated capabilities. And the question is, can we charge for it? So right now, Turbo, the basic service, which is monthly, not opt-in, opt-out, although you can opt out on a monthly basis, $7 a month. We're signing up around 7,000 to 10,000 subscribers a month. Well, you know, not terribly exciting. In a quarter, that means around 30,000-ish. But we churn, or we introduce, roughly anywhere from 250,000 to 500,000 subs a quarter. So you can imagine the number is quite small compared to the number of subs that we introduce in the network. But what we are starting to see is that people are interested, potentially, in paying for differentiated services. And you say, why start this on the consumer side? Well, the mass of our subscribers today are consumer-based. We are introducing the service now on the enterprise side, and we'll see. Will enterprise customers also be willing to or interested in paying for it? But this is really the promise. In order for 6G to really take off, we need more software-driven innovation, but we also need the 5G era to complete on a positive note. We need to be able to show that differentiated services can actually create value. And that's where software-driven innovation becomes important. And then finally, the opportunity for you all to contribute via open source and build testbeds and build capabilities that are AI-driven, intent-driven, without throwing around too many headlines. So what do we want actually from 6G? So I mentioned already AI native operations, and you hear a lot about AI today and how it will change the shape of the network, and should we put a GPU at every cell site? It's interesting to hear these arguments about putting GPUs at cell sites. It's probably not very different than putting GPUs in satellites and building satellite-based data centers. I'm sure many of you have, like me, deconstructed and tried to figure out, thankfully with AI, how big a satellite would have to be to generate 125 kilowatts of power. Anybody know the answer? No? It's about 70 meters across, 70 meters from one side to the other. Anybody know what the largest LEO satellite is today that has been deployed? 50 meters across. And that's AST. In fact, the first 3 truly commercial ones were successfully launched just last week. So this is going to require, and this was a big deal. AST set the record with Blue Walker 6, I believe it was 6. 7, unfortunately, was in a low orbit, so it will burn up too quickly. but 8, 9, and 10 are now fully commercial and now been captured. They've not unfurled the satellites completely, but yes, somewhere on the order of 50 meters across. So what they're proposing is, okay, to provide wide area coverage, we'll put up about 80,000 of these 70-meter across. So maybe some days we'll look up and we'll see it will be foggy and gray, but it won't be the clouds, it won't be moisture, it'll be satellites. So, but yes, AI native by design. Okay, what does that mean? It means that there's lots of places you can inject AI in the network, whether it's directly in the stack or in the layers above. So, but finally enabling the capabilities throughout the stack. Security has become really important overall, and this is motivating, and this actually helps, I think, motivate why you should study the stack and the stack behavior from an open source perspective. Today, somewhere, if you include network management, somewhere around 30% of the stack, yes, oh, someone's come in. Somewhere around 30% of the stacks are delivered with open source. They're not delivering things like LDPC encoding or decoding. They're not delivering equalization. They're not delivering schedulers. They're not delivering call admission control. But you can imagine there's a lot of data flow through the stack. And the data flow and the data management, even security, is managed with open source libraries. And this has become both an opportunity to reduce the size of a gross R&D team and to share between vendors on the implementation, but it also creates potential liability when people don't maintain their open source, when they don't actually take the latest versions of the library. So this is an area which is quite interesting overall. We're quite interested overall in replacing. We're one of the largest providers today of cellular IoT. I think us together with Vodafone are the largest in the world. Huge number of what are called Cat-M devices. Cat-M came very late in the 4G era. Now we are looking at making sure that in the 6G era, we get actually cellular IoT on day one. That capability is specified and standardized. Otherwise, like we saw with apologies to my Red Hat colleagues, RedCap. With RedCap, it came quite late again, and now we have enhanced RedCap, also potentially coming, again, quite late in the 5G era. So we really push quite actively to make sure at the beginning of the 6G era, we have the capability to support that. So I want to move a little bit faster, but I think just to simply get to, we know what the shiny object is for 6G right now. It's on my chart. Anybody guess what the shiny object is for 6G? At least in the US. I don't know if it's really truly you in Europe. Exactly. Everyone even hesitates. There's a lot of interest in ISAC. A lot of interest particularly in drone tracking. And we question a little bit of, should you make the entire cellular network now able to track drones when people are able to track drones today off the back of a pickup truck? So the question is, do you really want to build this capability into the network or not? We think it will evolve beyond just drones into people, into other objects, into environmentals, figuring out whether it's foggy or cloudy and what level of pollution might exist in the network. We think and should consider that one of the use cases for ISAC is actually the sharing of spectrum. Using the RAN itself as a sensor to detect when other sources are using it, and moving into more sophisticated sharing mechanisms. We have a significant challenge in the US that much of the mid-band spectrum that we want is encumbered, encumbered today specifically by military or other government uses. So we have to find a way to share the spectrum with them, and that's effectively another ISAC use case. We're also pushing quite aggressively for a new method for, apologies, early in the morning, talking is never great for your voice, so I'll go drink a little bit of water. So I talked a little bit about the needs particularly for us to have and cover continuous innovation versus a generational reset. We have made a lot of investment in the network itself. We're not alone, we're not unique. And I think NGMN in Europe has also pushed quite actively for software-driven, not forcing a complete renovation of the network. What we find is that new technologies are being introduced and capabilities are being introduced not on the G boundaries. So new spectrum comes, for example, without the benefit sometimes of. Can you guys hear me okay without the mic? Maybe I don't hold it. Is it okay?
I think we're good.
Okay. If you don't hear me in the back, just raise your hand, okay? Make sure I want to project. I think the acoustics are quite good here, actually. So I think the simple thing is we look at it from the perspective of we want to leverage what we have. Today, we started our journey on Cloud Run, so moving towards away from purpose-built towards what I would consider to be merchant-based compute. I like merchant as opposed to commodity, because honestly, only one company can build a GPU today that can perhaps address a telco stack. That's NVIDIA. Only one company today actually offers the full capability to onboard a 5G stack at commercial volume, at commercial capacity, and that's Intel. AMD could, potentially, ARM could, but they don't yet, mostly because they don't want to invest in dedicated instruction sets, they don't want to invest in dedicated hardware specifically for that. We think this is close to changing. We expect this to change in the next 2 to 3 years, that both ARM and AMD will catch up to NVIDIA and to Intel and have the capability to offer us with 4 distinct flavors of hardware, which will give us an opportunity to pick and choose what we want based on where we want to go. And this is actually where we are trying to lead compared to what we see with some of the other operators around the planet. And make sure that that option is available so that we have really a market-driven opportunity to choose the best solution. That doesn't sound like a commodity. We are not buying sugar, we are not buying rice. We are buying compute. And we want that compute to be something that runs flexibly. So today, for example, Linux runs on every platform. Linux runs on my phone. Linux runs on my watch. Linux runs in data centers. Is there an opportunity with open source, for example, to think about a scalability of platforms, growing from the small to the very big? I think it will take time to grow to the very big scale, to offer truly commercial service, and truly become a commercial offer. It may take a decade. But at the same time, as we go on this journey, it gives us the opportunity to continuously explore and bring in new silicon vendors without the ties of the old. The need for an incumbent, Ericsson or Nokia or Samsung or Huawei, to bless it, to say, hey, this is the approved solution. Now you're on board with open source and you prove that it runs on open source. And you start to present opportunities for enhancements. Which leads to, again, the real opportunities, I think, especially for researchers right now, is in ISAC, is in integrated sensing and communication. And you say to yourself, okay, I understand the problem. It's a radar problem. Let me use a cellular signal as a radar signal. Let me use my cellular equipment to listen for the reflections, listen for the impact of those signals, and then create some fusion between different sources and build them together. But where the real opportunities exist today is not just to use the data from the network, to use the data from other sources, from other radar systems, from video systems, from other drones, from UEVs, bringing them together in the cloud in a meaningful way. So this is where the opportunities, I think, are great, in particular improving the overall accuracy and performance of saying, I need to track speed, I need to track distance, I need to track size. And whether it's something in the air or something in the ground, I want to be able to do that. And I need researchers to help me get to a solution that is going to continuously scale. So we'll start with the use cases that we think, and there's a lot of pressure now from the US government and from other first responder agencies in the US today to offer services in the next 2 to 3 years. This is a tremendous challenge for us. We know that together with our partners, and we're working quite closely with Ericsson, and you'll see some press releases again from the local stadiums there from FIFA, and again perhaps around the 250th celebration for the US independence. There will be more noise, I'll call it noise, about ISAC in particular and what we are doing. I'm sure there will be noise from our competitors. I'm sure there will be noise from the overall supplier ecosystem about the ability to use drones, because it was stimulated to some degree by the US government. They actually specifically asked, can we stage demonstrations in a meaningful way in time for FIFA? So this is something that you will start to see in the press. And some of it is also driving now a desire, especially from the US government, to say, can we build, and there was an RFP issued through the National Spectrum Consortium, some of you may be aware of it, specifically to seed investments to build ISAC-based systems based on Okuda, based on an open source library. So we start to see this evolution that is happening very quickly. Now, I will tell you there are different flavors of open source, and I won't split hairs over which one is better than the other or which direction it is. But I'm here speaking today, so I hope that gives you a vote about what I think. So I believe in community-driven when it comes to open source. It is why I'm involved in ORAN, why I've been involved since its inception. Helped create it, helped spin from, some of you guys may have heard of XRAN, move AT&T to say, yes, converge XRAN with CRAN and create ORAN together with Verizon and together with China Mobile and with Docomo. At the early days of those conversations, so much promise, and just like 5G, so much lack of delivery. It's unfortunate. Hopefully this time around when we get to open source and the new buoyed interest in open source, we aren't sitting here 10 years from now and talking about why open source didn't work for 6G. We don't want that to happen. So it seems like there is a lot of partners that are also interested. I would say there was not so much partnership interest in open source in the OSC days when it was kicked off. It's good to see Ericsson as a partner and sponsor here. We, of course, were engaged quite actively, engaged in air quotes, some of you will know what that means, by the US government to involve ourselves in Okudo. And of course, we brought the ecosystem with us. We brought Ericsson, we brought Nokia, we brought Samsung with us because they said, okay, if AT&T is interested in Okudo. So this is why it is important for operators to lean in on technology initiatives and not simply say, bury their heads in the sand saying, I don't want technology. Do you guys remember I said, my boss said, I don't want 6G? I could have buried my head 3 years ago and said, okay, I'm not going to work on this anymore. I'm done with 6G. We'll wait and see what happens. Like I said, we'll wait and see. So I already kind of covered the slide and talked about AI native. What I wanted to really get to is to start to talk about where AI is evolving to. So we are deeply now into the agentic era. I think many of you, and I use it as a hobby, generative, to now speed read. I always wanted to learn how to speed read when I was a kid, but I've tried a couple of times and failed. I think I always get lost in the words. I'd stare at them forever. But AI, generative AI, has now allowed us to speed read hundreds of documents now. We get a summary. We get a clear, concise view sometimes. Sometimes it hallucinates. You have to be very careful. But it also generates things like, and you'll see maybe some of the slides in here. I actually honestly don't know anymore because sometimes my admin generates the slides or my chief of staff generates them, and she doesn't tell me whether she uses AI or not to generate the slides. I have a strong suspicion the slide was AI generated. I don't know. But agentic, now we know that we'll move to the next phase where, unfortunately, my chief of staff, well, maybe not unfortunately, she has a lot of things to do. In the future, she will write an agent so that whenever there is a request, it goes directly from my inbox to the agent to say, you need slides for a presentation, and generate the slides. That's what we look forward to. Is that a good thing? I'm not sure. The next step is, of course, replace me completely. I'm now autonomous. I don't come here anymore. Somebody wants to talk, wants to hear about it. They type, they say, oh, we would like to have Rob come and present. And instead of me coming and present, my avatar shows up, stands here, presents. I didn't have to travel to Porto, that would be so rad. Travel here, and you would hear or listen to my avatar at your desk. You don't even have to get up and listen. And it would tell you right away what is important about AI in the network. So there's AI for the network as well as AI readiness of the network. We work on both actually, because we think actually the biggest source of traffic coming in the network will be AI generated. We already start to see some inclinations of that. So what we see already is that we expect 2027 to be the big year when we start to transition from traffic, which is primarily human generated, into agentic generated. And this is going to be very interesting to see how it affects wireless traffic in particular. Is the wireless traffic growing at the same rate? So from my perspective, we start to already see an uplift in the uplink traffic. Where is it coming from mostly? People are streaming more. People are taking pictures and sending them more. But we also start to see things that appear on the network that generate additional uplink traffic. Let's go back to this. And where are those points coming from? So, how many of you have taken a ride in a self-driving car? How many of you enjoyed it? So, how many of you have taken a ride in a robotaxi? do you know what the difference is between a robotaxi and the other competing offers? Anybody know what the difference is? So robotaxi, some of us have probably heard Elon say, oh, I only have 2 eyes to see when I drive my car. Why do I need anything other than cameras to drive my car? And that too, why do I need anything more than 2? Well, they start to realize that 2 cameras is not enough. In fact, they put, I think, anywhere between 6 to 8 cameras on the car to be able to see and see in every direction. And of course, quietly, they also turn LiDAR back on, but they don't tell people about that. Instead, he tells people they turn it off. But what you find out is that for the robotaxi in particular, I won't pick on them, but I'll just simply say this is the reality. They're consuming somewhere on the order of 10 to 20 megabits per second per automobile. Does anybody know what a typical smartphone needs in terms of service rate that we would normally expect to provide in the network? 1 megabit per second. And this is continuously, for the time that it's connected, 12 hours a day, consuming 10 to 12 megabits per second on the airplane. So on a monthly basis, so a typical sub in AT&T's network would consume between 22 to 30 gigabytes a month. 22 to 30 gigabytes a month. They are consuming on the uplink between 5 to 7 gigabytes per day on the uplink. Consider too that 30 gigabytes for a typical smartphone user is 90% of the traffic is downlink today. 10% is uplink. So 3 gigabytes per month for a typical smartphone, 3 gigabytes. Versus they're consuming on a daily basis almost twice, or more than twice, what we get from a smartphone. So a huge shift in the way that the traffic pattern will change. And I think Ericsson Mobile Research document was just released this last week, and it starts to point to this. And we're seeing it, of course, in our network, but there's an increase in uplink traffic. Now, this is just a bellwether. This is just a pointer. There's traffic coming from a variety of sources. People are pushing more, whether it's through the Meta AI glasses or what we are calling living intelligence. This term was coined by Amy Webb. She's a futurist. She teaches at NYU, but she also has a boutique consulting company, and she's been advising the company, actually, actively on where we go overall next and what we prepare for in the network. And so she doesn't like to use the word robots. I don't know what she has against robots, but she doesn't like to use robots. But we already know, and we work with a number of robotics companies. Robotics companies today are struggling with the fact that they need up to 55 megabits per second of service rate on the network. 55. So you heard about the car, 10 to 12. Now we talk about a robot needing 55 because of all the sensors associated with the robot. And they're struggling to make it work. Even Wi-Fi does not provide enough capabilities. They're so focused right now, you probably see many of the demonstrations with robots, they have fiber optic cable running into the robot to keep it tethered. For those CAN demos where they show the robots dancing around, we know this is the largely CAN. They're not reactive. They're not truly autonomous. So in the end, we know there are lots of sources of living intelligence. There are devices in the network. You can imagine shared resources in laboratories that need to be interconnected. People are living in a distributed world and a remote world, but they need to gain access to devices which are highly connected, whether it's in a lab which is doing DNA sequencing or mixing potential new compounds for a drug and looking at the interactions, and sitting in India, but then the equipment is sitting somewhere in the US. This kind of thing is living intelligence, and this is emerging as a new thing. The question is how much of this will be on the cellular network, and how much of it will be finally on a Wi-Fi-based network. So for me, it's a good debate. It's a healthy debate of saying, will this network show up there? It's actually a question for all of us. Anybody want to guess today how much of your smartphone traffic actually goes over Wi-Fi versus cellular? So with roughly $30 billion being spent on an annual basis on cellular infrastructure, $30 to $35 billion a year, which is a lot of money. Today, 85% of your smartphone traffic is sent over Wi-Fi. 85%. So it's something that is, and actually it's a number that we try to continuously move the other way. We always want it to be higher. We don't want more traffic on the cellular network because often the experience isn't what the user wants, or it's the traffic is elastic and it can handle flexibility in data rates. It's not truly resilient. But these services, what we see, especially as they go outside are going to demand a new kind of network, a deterministic network, a behavior from an AI boundary to the edge of the network, which is predictable, it's reliable. And what is wireless? Neither predictable or reliable. But we're getting close to the end. So I'm not too far off, but I just want to get to remind you, and it was actually really good to meet with NVIDIA folks recently because there's a lot of noise in the US about AI RAN. And we said foundational for AI RAN is Open RAN. In order to enable Open RAN, in order to enable an AI RAN, you truly need an Open RAN. And so from that perspective, we feel like we are ready to, more directly than our competitors, to consume AI RAN when it's ready. No wine before it's time, so to speak. We waited on Cloud RAN to wait for Granite Rapids as opposed to consuming Ice Lake. This was an early generation of CPU. Right now, we are not going to consume Sienna-based software from NVIDIA. We'll wait, perhaps, for the Generation 3, Generation 4, probably the chipset. Probably won't be Grace Blackwell. Probably be the successor or the successor before we start to think about putting GPUs in cell sites. But all of that can be enabled finally through an open-based architecture with open APIs. So I kind of already covered it, but I just want to make sure that we get to what we are really looking for, really from the open source community. And these slides will be available. We'll release them, and you can always grab me on the side. But I just want to make sure that we continuously come back with this reference view of what we really want. So I start in the lower right-hand corner for a moment and just talk about open spectrum and open hardware. From our perspective, I mentioned all these new emerging hardware sources. So proving them out turns out to be a difficult R&D challenge for the incumbents. This is where there's opportunity for researchers to prove, hey, I can run on ARM. I can do an effective implementation of LTPC, which is fully soft without acceleration. I can do this on open hardware. I can consume new spectrum. I can look at new sharing models for spectrum itself as that spectrum becomes available. And that really gives back to the first point, which is flexibility and agility. An opportunity really to be flexible in how you explore and how you innovate. So for us, it's important, and we continue to drive, albeit with a smaller and smaller team, open standards interoperability. So we focus a lot on building labs that support this, and we use universities and university partnerships. We created a lab in Texas and in Virginia to test and validate concepts around Open RAN. We're doing that together with our direct competitor, Verizon, and there's a variety of universities that are involved. And we satellite and we work with other partners, including Northeastern, specifically in support of seeing testing and validation of new ecosystem partners who can bring this in. So what we look forward to is we start to see some of the devices that emerge, and the lab are truly open source driven, meaning they really leverage open source that's available in the community. And as we certify those, we start to move from the space of thinking that those things are just purely only for research use into things that become interesting for commercial use. So from our perspective, I mentioned already that 30% of the stack today is probably open source when you consider network management. We think there is more opportunity to explore this because we know R&D budgets are constrained. We know that ARPU is not growing, and so we start to move from a unlimited data plan into back of a more transactional plan. And frankly, it won't affect you. We're not suddenly going to start telling users, okay, you now have to pay on a per transaction basis. Today, you're paying on a per token basis when you consume many of these subscription-based services for AI. So we will hopefully participate in that token-based economy, and that will generate new sources of revenue. So for us, looking at the opportunities overall with 6G, we think this is an opportunity. Yes, this is through Linux Foundation. Yes, this is through, and you've heard this already about Kudu. I was very excited to hear already about the opportunities from Raymond about now thinking about can we bring OAI source code directly as a Linux Foundation repository. This is exciting. I think this will be interesting and give more opportunity for developers to pick and choose which source code library they choose to innovate on, but also move flexibly between bases. Less opportunity, less interest, I think, in OSC than there was in the past. OSC was primarily designed to enable the innovation on the rig, both non-real time as well as real time. We think we were pretty successful overall in stimulating ecosystem interest on the non-real time rig, less on the near real time rig for a variety of reasons, which I can't go into, but it would take a long time to describe them. But anyways, I think there is opportunity there. So let me just get to the end and just tell you where we are. So we think about what we want to do. We think about the opportunity really with open source to continue to experiment on virtualization, to continue to experiment on AI native, to really think about compute differently overall. really to start to think about using open source to help us with supporting interoperability and thinking about changing testing paradigms. I'm going to throw out another number for you. 1 in 3 integration engineers in our RAN partners, 1 in 3 engineers in their R&D community are currently supporting integration. 1 in 3. This could really change, I think, as you start to think about using AI-driven testing and reducing the number of engineers that are required to validate and test and certify a solution. Are we there yet? No. But we know that there's a lot of work being done. And I think this is, again, a place where you experiment with open source before you go to commercial stacks and start thinking about it. You build the tooling, you build the capability there, and you then validate it back on commercial stacks. We need to continuously think about also what is important for 6G. We could easily validate on what's the shiny object. We are going to drive towards a top 20 feature set. Top 20 features that we need to unify the industry to say this is what 6G really needs. Technology driven, but finally we need to involve our business partners. Does that technology, check, red-face test, does it generate an opportunity for new revenue? Okay, so with that I will turn it back. I will say that I appreciate you all for listening. We'll have more opportunity, I think, perhaps for questions during the panel, but really appreciate you guys. I think this was a good opportunity to both wake up both my voice as well as talk to all of you. Thank you very much.